Okay, so real quick, because I am super late, so I'm going to try to help y'all figure out what you would do with a decoder. So the way a decoder works is you have your inputs. So let's say this is a 2-to-1 decoder. So I have my two inputs, A and B. And A and B can be 0, 0, 0, 1, 1, 0, 1, 1. And I have my outputs 0, 1, 2, 3. If A and B are 0, 0, then my output would be 1, 0, 0, 0, because the 0 would be high because it's 0. If A and B is 1, 0, that's the number 2, and so my output would be 0, 0, 1, 0. So let's say I had a function of three variables, f of x, y, z, and it is the sum of min terms 1, 3, 5. Okay, then I would use a 3-to-1 decoder, x, y, z, and I would have those coming in here, and then my outputs, it's 3-to-1, so I'd have outputs from 1 to 7, 0, 1, 2, 3, 4, 5, 6, 7, and the ones that I would want to be high are the ones that correspond to these min terms. Because what is this function? This function is x bar, y bar, z, because that's 0, 0, 1, plus 3 is x bar, y, z, that's 0, 1, 1, plus 5 would be x, y bar, z. Kitty, please leave me alone. Is 1, 0, 1. And so that is what this function is. That's how this is defined. And so if any of these, if either 0, 0, 1, 0, 1, 1, or 1, 0, 1 is an input, that should give me a 1. And so I would want to OR together the outputs for 1, 3, and 5. Because if any of those is 1, then that is the value of my function. Okay, so how are you going to do this in Verilog? Well, first of all, Okay, so I interrupted the recording that I was making just to do a real quick insert on how you can quickly do a kind of sort of decoder, and then I'll come back and finish doing the real decoder later. So what you would do here, this is using the idea of a decoder, but we're not actually going to code a decoder that can be used for any kind of decoder at any time. It's just going to be very specific for our project. So I'm going to make a new project, call it Lab 5C. Next, I don't know if you can hear me because I'm in a public area right now. I don't know how loud I need to talk. I don't know, you might just be watching, don't know. Okay, so doing this, finish. I don't want to close it. I'm actually going to want to use the same constraints. So I'm going to go to my other project and get my constraints. Oh, I haven't made that one yet. Let's see. I want... Is this the one? This is the one. So I want those constraints. And plus next. So these are the constraints if you watch the multiplexer video. So Lab 5C constraints. Okay. Finish. Okay, so those are the same constraints as from the multiplexer. Alright, so now let's look at the design sources. Let's make a new source here. Create file, Lab 5C. Okay, finish, okay, yes, okay. Alright, so module lab 5C, our inputs are going to be A, B, C, D, and our outputs are S and T. Input A, comma, B, comma, C, comma, D. Output, am I going to have them in a reg? Yes. So we want to do like we did here, output reg. S, comma, T. Always at, so we want it to always be checking to see if A, B, C have changed, A, B, C, D. If those have changed, always at A, B, C, D, begin. Case, and then let's put together A, comma, B, comma, C, comma, D. Make one variable out of those. And then we'll have the values, the 4-bit binary numbers, 0, 0, 0, 0, all the way to 15. Okay, so you'll do that, and then you'll go all the way. I'm not actually going to do it, but you'll go all the way to 15. And then let's say that our function S is the sum of the min terms. So let's say S is S equals so S equals sum of the min terms of 1, 5, 1, 5, 11, 1, 2, 5, and 11. Let's say that's what S is. Okay, so then what we want to do here is we want S to equal 0.
If you don't want it, maybe the woman that you eat with, she might want it.
S equals 1 for 1, and S equals 0 for all the ones that are not in my min-term list. And then when I get to 5, that'll be 1. And then they'll all be 0 until I get to 11. So 8, for instance, would be 0. I'm sorry, 10. 10 would be 0. But 11 would be 1. So you're going to put this in for all of them. Then end case. And then you'll make another case for T. And then you can fill in all the values for T. and that's all you have to do, and that will do it. So hold on just a second. Okay, so I filled that all in. So I've got from 0000 to 0015, and I made S the sum of the min terms 1 and 5 and 11. And then I did the same thing for T. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, and then for T, I made it sum of the min terms 1, 0, 1, let's see, 8, 9, 10, 11, and 15. And then end case. Then I have to end my always block. And I have this extra here. And I can use the same test bench that I made for the multiplexer. So I can make a new simulation source. TV Lab C. Okay. Finish. Okay. Yes. And then I need this to be set as top. Change here is my unit under test. I have lab 5. I need that to be lab 5C because I wanted to use that function. Save. Save. Right now I'm going to ignore this and see if I can figure out what's going on. Let's see. I want, that is the one I want. Lab 5C, save. What did I call it? I did call it Lab 5C. Test bench Lab 5C, unit under test bench Lab 5. Lab 5C unit under test. I think that should be okay. Let me set that as top again. We'll see what happens. Let me do an elaborated design. Have in your book the code for a 2 to 4 decoder right here. So we have using a case statement. Let's see, we have 2 different 2 to 4 decoders. Let me see what the difference is. just two different ways of doing it. So it has an enable input, and when the enable is 1, then the decoder works like we were talking about. When the enable bit is 0, then the decoder just gives a value of 0, 0, 0, and that's just done in two different ways in this code. And then we have on the next page making a 4 to 16 decoder out of using these 2 to 4 decoders. Well, you are supposed to have a 3 to 8 decoder. So how would you do a 3 to 8 decoder? Well, you wouldn't need as many of these. So let's see how we could modify this. So we would let's take our 2 to 4 decoder, I am so late. So I'm only going to do a little bit more, and you're just going to have to figure out the rest yourself. Alright, so we've got so this is not going to be my main lab, just like in the other one we instantiated the multiplexers. This is going to be up here. Yes, I want to convert to their ASCII equivalents. Okay, so this is a 2 to 4 decoder. That takes as input a 2-bit variable W, and based on W, so W is 2 bits, and so it's the second the last 2 bits of this, 0, 0, 0, 1, 1, 0, 1, 1. The first bit, so it's this case statement is taking the enable bit first. So the enable bit is either 1 or 0. It's 1 if it's enabled, 0 if it's not, and then taking the 2-bit W. And so if W is 0, 0, then our output has 1 in the 0 position. This is backwards of the way I like to do it. I'm going to make this 3 to 0, and I'm going to put it like this. Now, I like this better. So this has, if it's 0, 0, I have a 1 in the 0 position. If it's 0, 1, I have a 1 in the 1 position. If it's 1, 0, I have a 1 in the 2 position, and if it's 1, 1, I have a 1 in the 3 position. If I am not enabled, then I have, it's all zeros. Okay, so that's a 2 to 4. Now I want to make module decoder 3 to 8. and I'm going to base it on this one. Okay, so I'm going to have my inputs are going to be W and enable, and my output will be Y. My input is 3 bits, so 2 to 0 and enable, and my output is going to be 7 to 0. And I have this wire M, and then I will have my first decoder. So I'm going to be getting Y is going to have all of my outputs. So let's see if we can do this just with this. And our wire only needs to be 0 to 1. Okay, so this decoder gives us our output is a 4-bit value. And